In this final section, we're going to review freshwater, beginning with the polar ice caps. Polar ice caps are dome-shaped sheets of ice found near the North and South poles. You can see them in the image. They form because high-latitude polar regions receive less heat from the sun than other areas on Earth. As a result, average temperatures at the poles can be very cold. The polar ice caps contain the majority of Earth's supply of fresh water. In fact, scientists estimate that 70% of Earth's freshwater supply remains in an ice sheet at the South Pole. Average temperatures at the poles have begun to rise in recent years due to changes in the environment. As temperatures rise, the polar ice caps start to melt and break apart. NASA satellite photographs show the polar ice caps are shrinking 9% every 10 years. The changing environment at the poles affects native people, animals, and plants. Animals such as seals, polar bears, and whales may be forced to change their natural migration patterns. The effects of the melting polar ice caps may one day be felt well beyond the poles. As the polar ice caps shrink, sea levels begin to rise, creating serious problems for coastal areas around the globe. Glaciers. Glaciers are made up of fallen snow that over many years compresses into large, thickened ice masses. Glaciers form when snow remains in one location long enough to transform into ice. What makes glaciers unique is their ability to flow. Due to sheer mass, glaciers flow like very slow rivers. Some glaciers are as small as football fields, while others grow to be dozens or even hundreds of kilometers long. Most of the world's glaciers are found near the poles, but glaciers exist on all of the world's continents, even Africa. Glaciers not only transport material as they move, but they also sculpt and carve away the land beneath them. A glacier's weight, combined with its gradual movement, can drastically reshape the landscape over hundreds or even thousands of years. The ice erodes the land surface and carries the broken rocks and soil debris far from their original places, resulting in some interesting glacial landforms. Common all over the world, glaciered valleys are probably the most readily visible glacial landform. Similar to fjords, they create U-shaped valleys, often with steep, near-vertical cliffs where entire mountainsides were scoured by glacial movement. One of the most striking examples of glaciered valleys can be seen in Yosemite National Park, where glaciers literally sheared away mountainsides, creating deep valleys with vertical walls. Icebergs. Icebergs are large chunks of ice that break off from glaciers. This process is called calving. Icebergs float in the ocean but are made of frozen freshwater, not saltwater. Most icebergs in the northern hemisphere break off from glaciers in Greenland. Sometimes they drift south with currents into the North Atlantic Ocean. Icebergs also calve from glaciers in Alaska. In the southern hemisphere, almost all icebergs calve from the continent of Antarctica. Lakes and ponds. Lakes and ponds are formed from glaciers, volcanoes, and tectonic activity. Lakes and ponds are very similar. In general, lakes tend to be larger with both an inlet and outlet of water. Ponds tend to be smaller with just an inlet of water and no outlet. Imagine a giant glacier melting and retreating. A large void in the ground emerges and then fills with water. The Great Lakes were formed this way. Imagine a volcano erupting. The explosion blows the top of the volcano out. This creates a basin that can become a lake, called either a crater lake or a caldera lake. The namesake Crater Lake in Crater Lake National Park is one such lake with a depth of about 1,900 feet. An earthquake can open up a hollow in the land that will become a lake. Albert Lake in Oregon is an example of a tectonic lake. Another type of lake is the dune lake, which is formed when sand blocks river mouths that lead to the ocean. And of course, People can create artificial lakes by digging a big hole and filling it with water, or by creating a dam to stop the flow of a river. Streams. Streams are bodies of water that have a current. They are in constant motion. Geologists recognize many categories of streams depending on their size, depth, speed, and location. Streams can be creeks, brooks, tributaries, bayous, or rivers. In streams, water always flows downhill, but the form that downhill movement takes varies with rock type, topography, and many other factors. Stream erosion and deposition are extremely important creators and destroyers of landforms. River and stream erosion are different from glacial erosion because rivers create more pointed V-shaped valleys. Rivers. Rivers are the largest types of stream, moving large amounts of water from higher to lower elevations. The Amazon River, the world's river with the greatest flow, has a flow rate of nearly 220,000 cubic meters per second. People have used rivers since the beginning of civilization as a source of water, food, transportation, defense, power, recreation, and waste disposal. Rivers and streams complete the hydrologic cycle by returning precipitation that falls on land to the oceans. Ultimately, gravity is the driving force as water moves from mountainous regions to sea level. Some of this water moves over the surface, and some moves through the ground as groundwater. As this water flows, it does the work of both erosion and deposition. River deltas. Deltas are wetlands that form as rivers empty their water and sediment into another body of water. A river moves more slowly as it nears its end. This causes sediment, solid material carried downstream by currents, to fall to the river bottom. Like most wetlands, deltas are incredibly diverse and ecologically important ecosystems. Deltas absorb runoff from both floods from rivers and storms from lakes or the ocean. Deltas also filter water as it slowly makes its way through the delta's distributary network. This can reduce the impact of pollution flowing from upstream. Groundwater. Groundwater is the water found underground in the cracks and spaces in soil, sand, and rock. It is stored in and moves slowly through geologic formations of soil, sand, and rocks called aquifers. Groundwater is used for drinking water by more than 50% of the people in the United States, including almost everyone who lives in rural areas. The largest use for groundwater is to irrigate crops. You can see here that groundwater fills the spaces between the soil particles and fractured rock beneath the Earth's surface. Aquifers. Aquifers are typically made up of gravel, sand, sandstone, or fractured rock like limestone. Water can move through these materials because they have large connected spaces that make them permeable. The speed at which groundwater flows depends on the size of the spaces in the soil or rock and how well the spaces are connected. Aquifers can occupy huge areas covering multiple states. Water table. The water table is the upper surface of the zone of saturation. The zone of saturation is where the pores and fractures of the ground are saturated with water. The water table can be thought of as an imaginary line. Above this line, there may be moisture in the rocks and soil, but it is not fully saturated. Below the water table, in the saturation zone, the rocks and soil are fully saturated. All pore spaces are full of water. So you can see that here. This imaginary line is our water table, where above that there may be some water, but it's not fully saturated. And below that, it is fully saturated. The depth of the water table can vary seasonally and with environmental conditions such as rainfall and snowmelt. When removing water from the ground, the local water table will move farther into the ground, forming a cone of depression. So this well removes water locally from the water table. When we remove the water, Water will flow in as some is coming out, and the water table here lowers, creating this cone of depression. When groundwater is removed faster than it can naturally replenish, the water table becomes depressed, wells can dry up, salt water can intrude in coastal locations, and the earth can subside. Subsidence of the earth is just that vertical movement downward of the earth, as you can see here.